Welcome. We're going to have some fun today talking about HVAC and DHW electrification opportunities. Before we begin to electrify, we want to make sure we eliminate waste, improve efficiency, recover heat, get our house in order, and then we can start considering electrification. That's also probably financially the most attractive pathway.
Electrification, we're converting a system to use electricity. Low carbon electrification, or LCE as we'll refer to it in today's session, is converting a system that was previously using that carbon intensive fuel to the use of a lower carbon electricity source. In jurisdictions where we have a lower grid intensity for emissions, the low carbon electrification can tend to make more sense. We're trying to balance this kind of, in some ways, bit of a golden triangle here, trying to do what we can to reduce emissions on site, to be a good grid citizen, and also to try to do it in a cost-effective, strategic way.
What is a heat pump and where does it get its name? What you're really doing is you're taking heat at a low temperature and doing some work upon it and actually delivering heat at a higher temperature. So in a sense, I like to think of it as making the heat more valuable. Many of you will know that a heat pump device can also provide air conditioning. The coefficient of performance, or what I called efficiency earlier, for heating, right, is how much heat do we get for how much electricity, in this case, we have to put in to run that heat pump. Well, if we get 3 kilowatts out and we put 1 kilowatt in, then we say that we have a coefficient of performance of 3. And again, that sort of parallel to efficiency, that would be like a 300% efficiency.
Domestic hot water heat pumps, we've mentioned them, we haven't talked about them too much. Very similar in terms of their operation. We are pulling heat from the air and using it to heat the domestic hot water that we need to use in our buildings. The technologies we've been through here, gas-fired boilers, gas-fired rooftop units, gas-fired domestic hot water, and then on the right-hand side, what some of those replacement options are. So design considerations, heat pump systems. There's so much that we do need to consider, particularly with retrofits, which is why it's complex. We want to make sure that we do it right, that we're not rushing, that we're taking things into account, we're using a good design team and making sure that we're involving our operators in those decisions. Other things to think about, reducing the heating and cooling loads first. Right back to the start here where Stephen said, we need to make sure that we're hitting steps 1, 2, and 3 before we move into this more expensive and more complex upgrades of decarbonization. What is the data that we might have to inform the design? Michelle gave that great example before where we use the utility data to say, what does that load profile look like? How is that going to impact our design and how we might operate this system once we get it up and running? And I'm going to pass over to Stephen here, who's going to share a bit of an example and give us a little demo in terms of how we might use RedScreen as a tool to help inform the design.
So what RedScreen will do for me, once I input these 4 numbers, floor area, the fuel type, the efficiency of the system, it will estimate for me the heating load of the building. So RedScreen can be used to do those kind of preliminary calculations, get an idea of where it lands, and actually eventually do your financial analysis. Commissioning is incredibly important in these systems for proper and effective and cost-effective operation. Most buildings and most organizations will have some kind of asset renewal program. And I think one of the simplest, but maybe the most effective suggestions is to make or add energy and/or carbon impact, energy cost, carbon impact, as a prioritization criteria.
Remember to join and sign up for the next session.